Okay, in this video, I'm going to be talking about how to solve problems that, in our review, we've labeled as problem type A. So this is originally objective 5.2 one-step trig equations. If you are having trouble with trig equations in general, this is probably the best place to start, as this is kind of the basics for the rest of the problems we've learned how to solve. So I'm going to do these three problems. So we've got a cosine problem, a cosecant problem, and a cotangent problem. There are also sine, secant, and tangent problems, but they're going to be very similar to one of these three. All right, so let's start with number one here. Cosine theta equals 0.6 degrees. So for most of these problems, you're going to expect to find two answers. Remember that all of these answers refer back to the unit circle, in which we have multiple values that repeat several times. Cosine, for example, is talking about the x value on our unit circle, which means you may have two answers like this, where they have the same positive x value, or two answers like this, where they have the same negative x value. The only exception, the times when you're going to have only one answer, would be if you have an x value of 1, and that means that we are on the positive x-axis, or an x value of negative 1, which means we're on the negative x-axis. These are the only two situations where it doesn't just reflect over. It also does apply if we have x value of 0. That one is one that sometimes trips people up. So just keep those in mind. These are the two that you're only going to get one answer for. And this one there is also a second answer because it can be 0 in two places. So just make sure you remember to do that. Give me just a second. I'm going to adjust my camera. Okay. To get our first answer, you are typically going to want to use a calculator. Some of these you can do just from what you remember about the unit circle, but most of the time you're going to want to use inverse cosine. So for this one, to get my first theta, I'm going to use inverse cosine of 0.6 in my calculator, hit enter, and it gives me this number. So this is in degrees. So this means one of my thetas is 53.13 degrees. Now to find my other answer, I need to think about where that angle is on my unit circle. 53.13 degrees is between 0 and 90 degrees. It's right about here somewhere. And that is when my x is equal to 0.6. My other answer, where x is equal to 0.6, needs to be in the lower half of my coordinate plane, or in the fourth quadrant. And to find that angle, we need to start here and measure all the way around to the terminal side in the fourth quadrant, which the whole thing would be 360 degrees. This is 53.13 degrees, which means our second theta is going to be 360 minus 53.13 degrees, which is going to give me 306.87 degrees. So if I asked for angles, or theta, that is between 0 degrees and 360 degrees, then the two answers that you would tell me would be 53.13 degrees and 306.87 degrees. Of course, if I asked for all angles, you have to remember that, yes, these are two answers, but that's only within one rotation. To get other rotations, you just have to keep adding 360 degrees. Every time you add 360 degrees, these two angles repeat. So we would say 53.13 degrees and 306.87 degrees. Those still stay. But of course, I can't list all of them. So the shortcut is to say plus 360 degrees k for each one. And that will tell us all of the angles that satisfy this equation, whereas this one tells us all of the angles that satisfies the equation within one revolution, between 0 degrees and 360 degrees. Okay, let's try another one. So problem number 2 was cosecant theta equals negative 2.4. Most of you do not have a calculator that has an inverse cosecant function. If you do, that's great, and you're welcome to use it. Most people don't, unless you have probably a TI Inspire. But if you're working with a calculator that doesn't have it, it's okay. Remember that cosecant theta, based on our reciprocal identities, is equal to 1 over sine theta. It is 1 over sine, not cosine. Don't let the co throw you off. Cosecant is 1 over sine. So we can rewrite this to be 1 over sine theta equals negative 2.4. Of course, this fraction is kind of a problem, so we're just going to take the reciprocal of both sides. So this will become sine theta, and this will become 1 over negative 2.4. So sine theta is equal to 1 over negative 2.4. So now, to get our theta, we just have to say inverse sine of 1 over negative 2.1, or 2.4, sorry, which is simple enough to do. Be very careful with your parentheses. But we will say inverse sine of 1 divided by negative 2.4. And we get a negative angle, negative 24.624. This is a point where some people get confused. We have to keep in mind what the question is asking. So if we want angles that are between 0 degrees and 360 degrees, this is no good. This is obviously less than 0, so it doesn't work. If we want all angles, it is acceptable, but most of the time we want to get in the habit of finding the positive version of this angle first. So figure out where that is. Negative angles, remember, just mean you go clockwise instead of counterclockwise, so we're in quadrant 4. And I'm just going to go ahead and take the absolute value of this. The negative just tells me the direction. I don't care if it's positive or negative when I'm measuring it. So this is a 24.624 degree angle. Of course, it's measured in the wrong direction. To get the other measurement of that angle, I just need to say 360 minus 24.624. And I get approximately 335.376 degrees. So that is one of our answers. So if I was solving for theta between 0 and 360, I have theta equals 335.376. You can round that to 3.8 if you'd like. Now, I need to figure out if this is a 24.624 degree angle, where is the other angle that gives me a y value of 1 over negative 2.4? Well, since it's y that we're talking about, we need to look at the y-axis, and we need to reflect this angle to the other side of the y-axis, which puts us in quadrant 3. Remember, sine means you will reflect over the y-axis, whether we're in quadrant 1 reflecting into quadrant 2, or quadrant 3 reflecting into quadrant 4, or I'm sorry, 4 into 3. And now, to measure this angle, this is also a 24.624 degree angle, just like this one was. I need to measure from 0. So this straight angle will be 180 degrees. And then this 24.624 degree angle just means I need to add 24.624 degrees. So we could do that math, but I've got a calculator right here. I'm going to go ahead and use it. 180 plus 24.624, and we get 204.624. So our second angle is 204.624. Now that's for between 0 and 360. And notice that the angles up here can't be solutions because y is positive up here, whereas our y in the problem was negative. Sine being y, we only have negative solutions, which means we need to be in quadrants 3 or 4. To turn 0 to 360 degree solutions to all solutions, we simply need to take into account that there could be more than one revolution. So I'm going to put them in numerical order just because I feel better writing them that way. 204.624 degrees plus 360 degrees K, and 335.376 degrees plus 360 degrees K. So our original problem, cosecant theta equals negative 2.4, produces these solutions. These are all the solutions between 0 and 360. Note that there are two of them for all angles, so that's less than 0 and greater than 360 and everything in between. We have an infinite number of solutions denoted by this K, which tells us our answers could happen multiple different ways. And we have one more problem. So the last problem I'd like to look at is cotangent theta equals 10. Now, once again, most of you do not have an inverse cotangent button, but you do have an inverse tangent button. So we're going to use our reciprocal identities to rewrite this as 1 over tangent theta equals 10. And because we don't want this fraction here, we will take the reciprocal, and that turns that into tangent theta. And this 10 will become 1 over 10. I took the reciprocal of both sides. And from this point, to get theta, I just need to do inverse tangent of 1 over 10. So we will do inverse tangent of 1/10, and we get 5.71059. You can round that a little bit. I'm going to say 5.71 degrees. And now let's think about where that is on our unit circle. 5 degrees, it's not very big. That's definitely in quadrant 1. Now tangent is a little bit different than sine and cosine. Sine, I would need to reflect this over the y-axis. For cosine, I would need to reflect over the x-axis. For tangent, I actually need to reflect it across this diagonal line that passes through the origin, which means my second angle, if my first angle was in quadrant 1, my second angle would need to be in quadrant 3. If my first angle had been in quadrant 4, my second angle would need to be in quadrant 2, and that's the pattern you're going to use for tangent. And of course, this is going to be directly across, which means there is exactly 180 degrees between them. So to get my second angle, I simply need to do 180 degrees plus 5.71 degrees, and that's going to give me 185.71 degrees, and that's my second angle. So if I'm looking for my angles that are between 360 degrees and 0, of course that means there is one rotation, just one rotation around the unit circle, then my two answers would be 5.71 degrees and 185.71 degrees. Note that they are both positive. They are both between 0 and 360 degrees. These are the only two solutions that happen in here. If I went the other direction, I would have a negative angle. If I went around again, or if I ended up back over here, it is now greater than 360 degrees. Those are the only two that happen within one revolution. But when I ask for all values of theta, or all angles, there are an infinite number of solutions. So we have two methods when it comes to tangent. You could keep doing what we've been doing and just do 5.71 degrees plus 360k, and theta equals 185.71 degrees plus 360k. Or the second option, and this is the option that I prefer, because it does save a little time sometimes. If you know up front that you're going to have to find all values of theta, not the values between 0 and 360, save yourself some time and just say your first angle that you found. And since we know this one is 180 degrees away, and then the next one will be 180 degrees away, and so on, I don't have to find a second angle. I just say plus 180k. Now both of these are correct. Method 2 says the same thing that method 1 does, and if you're looking for all values of theta, this one will sometimes save you some time. So just keep in mind, writing it this way is optional, but you are welcome to do it that way. The most straightforward way is going to be to find these two solutions and then add 360k to turn it into all solutions. But I'll leave it up to you whichever method you prefer.